Okay. All right. So again, we are going to talk about equation of circles, and this time around the situation is different. I'll write down this question. It's basically a book question, and I've seen such questions in past papers as well. So let's talk about it. Okay. Question number 1 for this class. Okay, now the question says a circle passes through the points P and the coordinates of P are -1 and 4. Then Q with 1, 6 and R with 5, 4. And you have been asked to find the equation of the circle. So it says find the equation of the circle. Okay, now please pay attention. The concept that we are going to discuss in this example is something similar to what we did in the last class. So it says a circle passes through the points P, Q and R. Find the equation of the circle. So first of all, let's quickly know that for the equation of circle, we need the radius and we need the center. And somehow using the given information, using PQR, I need to find the radius and I need to find the center. And then I would be able to find the equation of the circle. So before talking about anything, let's talk about how exactly this would look like on the diagram. So let's make a circle for now to understand the concept. So let's say this is my circle. And on the circle, we have a point P. And the coordinates of P, let me just write down P. Then we have Q. And then it's R, okay? All right, P, Q, and R. So these three random points are given on the circle. And you need to somehow use them and then find the center and the radius. Now, as I've told you earlier as well, using these 2 points, just like in one of the previous questions, we had 2 points A, B, and the examiner did not mention that AB was the diagram, was the diameter, okay? So just like AB, PQ are 2 points, and when I will connect PQ, this is just giving me a random chord of the circle, okay? Similarly, if I connect these 2 points, QR, this is going to give me another chord. So PQ and QR are basically 2 chords of the circle. And now we know if I make a perpendicular bisector for PQ and if I make a perpendicular bisector for QR, both of them are going to be diameters. Why? Let's do that and then let's see. PQ is a line segment. I'm interested in finding out the perpendicular bisector of PQ. So let's say this is the midpoint of PQ. I will make a line that is cutting PQ at 90 degrees angle. Okay, now this certainly looks like the diameter, but I'm not going because of the appearance. I know that this is a property that whenever I will perpendicularly bisect any chord of the circle, that is going to be the diameter. Okay, similarly, I have QR now, and now if I make the perpendicular bisector for QR, so first of all, bisect means center and then perpendicularly. So I am going to make a line and it's going to be something of this type. And again, this is the diameter. Now, we know if we have a circle and if we have 2 diameters, obviously their point of intersection is going to be the center. When I made the second diagram, now you can say that it looks like it is center, but not necessarily. We are not saying this because it looks like it is the diameter. No, it is the diameter. Just remember, let me write this note over here. Perpendicular bisector of any chord is the diameter of the circle. Please remember this. Always remember this. This is very, very important. Okay. So perpendicular bisector of any chord is basically the diameter of the circle. And we had 3 points. Using those 3 points, I was able to make two chords. And I know if I have two chords, I can make two perpendicular bisectors. Both of them are going to be two diameters. I can find their equations. And when I will solve these equations simultaneously, I would get the center, and once I have the center, I can use P, Q, or R and the center to find out the radius. So any difficulties with the concept behind the question?
No, miss.
Okay, very good. And Munja, what about you? Anything that you would like to ask?
Okay. No, no, ma'am. I'm comfortable with it.
Okay, perfect, perfect.
Yeah.
Okay. All right. So now we know that first of all, we need to find out the equation of the perpendicular bisector of PQ and then perpendicular bisector of QR. So let's do that. So okay. Equation of the perpendicular bisector of PQ. So for that, I need to find out the midpoint of PQ. Midpoint of PQ. And how do we find out the midpoints? That's very simple. So we are just supposed to add the x coordinates and then the y coordinates. Very good. And then we'll divide them by 2. So -1 and 1. This would give you 0. And 4 and 6 would give you 4 plus 6 would give you 10. So this way, the midpoint is going to be 0 and 5. Okay. This is the midpoint of PQ. Okay. Number 2, we need to find out the gradient of PQ. Why? Because when I will find the gradient of PQ, I would be knowing the gradient of a line that is perpendicular to PQ by finding out the negative reciprocal. Okay.
Mm.
So M of PQ is going to be, so it's y2 minus y1 divided by x2 minus x1. It would be 6 minus 4 divided by -1 minus and then -1 in brackets. And this is going to give you 1. Okay. So the midpoint was 0, 5 and the gradient of PQ is 1. I need to find out the gradient of the perpendicular bisector. So I'll write it down this way. M dash is going to be -1. Okay. Now I am in the position to find the equation for the perpendicular bisector of PQ.
Miss.
Yes.
Miss, can you go up?
Yes, certainly.
Miss, the coordinate of Q is 1, 6, not
Yes.
-1.
No,
Miss,
no,
right,
it's for P. 1 second, 1 second. It's y2 minus y1 and then x2 minus x1. Yes, 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 that's right. That's right. And yes, it is going to be, yes, the answer is correct. 6 minus 4 is 2 and then 2 divided by 2 is 1, right? So this happened by mistake, okay? But thank you for mentioning this. You are right. Okay? Yes.
Okay.
So the gradient of PQ is 1 and the gradient of the line that is perpendicular to PQ is basically going to be the negative reciprocal of this, and that is going to be -1. Okay, this is correct. I'm checking it again and again. Okay, don't worry about it. And now we need to find the exact equation. So for the equation, it is y minus y1 equals m x minus x1. Now this is basically the equation of the perpendicular bisector of PQ. So y minus this point that is lying on the perpendicular bisector, that is 5, equals minus 1 into x minus 0. There's no point in writing down that 0, but let's just write it down for the sake of completeness. And this would give you y equals minus x plus 5. So this is basically equation 1, and this is the equation of the first perpendicular bisector. So the equation of this turned out to be y equals minus x plus 5. This is basically the equation of the first perpendicular bisector. Okay. Any confusions with this?
No, miss.
Okay, now can you guys find out the equation of the other perpendicular bisector in like 2 minutes? For QR, the method is again the same. I'll show you the coordinates of QR. This is Q and this is R, okay? Just take 2 minutes and quickly do it, and then I'll write down the equation directly, because now you guys should be in the position to find out the equation of perpendicular bisector.
Miss, it's 2x negative 1.
Very well done, excellent. Okay, Munja, I'll wait for you for another minute, okay? Please try doing it with us, and then we'll continue it. You should get this. I'm writing it down over here. The equation for the perpendicular bisector of QR is y equals 2x minus 1. That's correct. It's y equals 2x minus 1. Yes, Munja, are you getting the same equation?
Sorry, ma'am.
Are you getting this 2x minus 1?
My midpoint is 3.5. Then I'm just
Yes, that's correct.
my gradient is it's 2.
Yes, your gradient is 2 for the perpendicular bisector, right?
Yes, yeah.
Very good, very good. Yes, and then when you will plug in all the values, you would get y equals 2x minus 1. Excellent, okay? So
Yeah,
this
that's the
means
one,
that
yeah.
both of you were able to find the correct equations. And now what's next? Using these two equations, we can solve these two equations simultaneously. And this would give us this point. And what is this point? This point is basically the center of the circle. Okay, so now I am going to solve these two equations simultaneously. Equation 1 was y equals minus x plus 5, and the second equation is y equals 2x minus 1. This is the second equation. I can just equate both the y's, and this would give me minus x plus 5 equals 2x minus 1. I'll take this 1 here and I'll take this minus 1 on the other side. So 5 plus 1 equals 3x, and this would give you x equals 2. So this implies that 6 equals 3x and x is equal to 2. Now we have x is equals to 2, and using this thing I am going to find out y. So y is equal to minus x plus 5, and then y is equal to minus 2 plus 5. So y is equal to 3. Okay, I got y equals 3 and y equals 2. These are the two values. It's 2 and 3. And using this 2 and 3, I can find out the radius of the circle. So how can I find out the radius? Now I know that, let me just clear these lines. Okay, now I know that the distance from P to center, the distance from R to center, the distance from Q to center, all these are basically going to be the radius. This is the radius, this is the radius, this is the radius. So I can use any point PQR and the center to find out the radius. Okay, so for finding out the radius, let's do that. We can use any combination. So the center was 2, 3. That's the center. And then point R was basically 5, 4. I can apply the distance formula to find out CR. CR is basically root. And now I am going to write down the formula. X2 minus x1 squared. So 5 minus 2 squared plus 4 minus 3 squared. And this is going to give us root 10. So this implies that R is equal to root 10. And center turned out to be 2, 3. So let's just plug in the values of center and R in the equation of the circle. That is x minus 2 whole squared plus y minus 3 whole squared equals its R squared. So it would be 10. So this is going to be the final equation of the circle. Yes. Any confusions in this question? Anything that you guys were not able to understand?
No method. Clear.
Okay, perfect. And what about you, Munja? Anything that is coming to your mind?
Yesterday I did a similar question like that, but what I did is different method. I think maybe a method is more clearer. What I did was to find two midpoints for like the two midpoints from the two chords.
Okay, okay, yes.
One of them, I did two questions, but they came out the same. Like find the midpoint of P and Q, midpoint of Q and R. Then one of the midpoints there will always have one of the coordinates already given in the question. Then the coordinates that are left out at the center of the chord. And when I checked with the scheme, it seems like it was the same. But I think your method that you've just indicated here, it's better, because I think it's better to find the equation of the two
Of the two perpendicular bisectors, yes.
Yeah, and then put the two to find the center. I think
No,
my
but
method I used yesterday was.
But if you were getting the correct answer, or what I was able to understand is that you first calculated the midpoint of PQ, then the midpoint
Yeah.
of QR, and then what exactly you have done?
Yeah, then when you put the coordinates together, like the P and Q and QR midpoints, one, if you put a cross lines between the coordinates, one of them will always be one of the coordinates of the given point on the sequence.
Okay.
Then the remaining coordinate will be the one for the center. I did twice I had 2 or 3 questions like that.
Okay, okay,
But
okay, okay, okay. Yes, yes, yes.
but I don't think so. That I mean, my method is okay though.
Yeah, no, no, no. If this method is working for multiple questions, this certainly would be the correct method. You can just send me a picture of your working, and then I would be, I would be able to understand it even better. But obviously, when you will look at marking scheme, it's not just that there's just one method of doing a question. You will certainly see method one, then alternate method. So if you're getting a correct answer and if you're comfortable with some other method, that's completely fine. Okay. And it's not necessary that the marking scheme has all the methods. Like, just trust me. Just send me your working. I'll check your working and I'll see if it's mathematically, or if if all the properties exist the way you have used them, and then I'll tell you if you can use this every time or not. Okay.
Okay, I'll send it to you.
Okay. Okay. All right. I'll check it after the class. Okay.
Okay, take care.
All right. Perfect. So another question, and this is very important. This question is basically about circles and tangents. Okay, so this is the last question, then we'll talk about a past paper question. It's question 2, but it's very, very important. Okay, it says, show that the line y equals x minus 13 is a tangent to the circle x squared plus y squared minus 8x plus 6y plus 7 equals 0. Okay. So you need to show that the line y equals x minus 13 is a tangent to the circle x squared plus y squared minus 8x plus 6y plus 7 equals 0. Okay. Now, first of all, just think about what exactly is tangent. Okay. So imagine if this is your circle, and if I say that this is the tangent line somewhere here, so basically there would be a line that is touching the circle at one point only. Not like this, but something of this type. Okay, something of this type. It's touching the circle at one point only. So this is basically the tangent line. And obviously the pink thing is a circle. Now I can make this tangent over here as well. I can make the same tangent over here as well. I can make this tangent anywhere. So they have given you the equation of the tangent and the equation of the circle, and you need to show that the line is basically a tangent to the circle. Okay, this is what you need to prove. Now,
Okay.
one thing that you guys need to understand, that the tangent is going to touch the circle at one point only. So if we talk about the points of intersection of the line and the circle, how many points of intersection should we get? One point of intersection only, because obviously the tangent line is touching the circle at one point only. If I have a line like this is not tangent, and certainly I would get 2 points of intersection. If I have a line of this type, again I would get 2 points of intersection, and this is how I would know that both these lines are not tangents. But if I get 1 point of intersection when I will solve these two equations, this would imply that this line y equals x minus 13 is certainly a tangent to the circle, right? Are you guys getting the concept behind it?
Yes, miss.
Yes, ma'am.
Okay, perfect. Very good. Excellent. So it's very simple. I am just supposed to solve these two equations simultaneously, and then if I get one value for x, that would imply it is a tangent line. Okay. So I have x squared plus y squared minus 8x plus 6y plus 7 equals 0. I'll use y equals x minus 13. Where exactly in this equation? So x squared would remain as it is. x minus 13 squared minus 8x plus 6 into x minus 13 plus 7 equals 0. Let me check if I've written everything correctly. Yes. Okay. Now I need to expand and then simplify. So for this, it's x squared plus x squared. I'm expanding this now. It's x squared minus 26x and then plus 13 squared, that's 169, minus 8x plus 6x. Then we have minus 6 into 13, that is 78. So it would be minus 78 plus 7 equals 0. We have 2x squared, then minus 26, minus 8, and plus 6. So this would give you, just simplify all the x terms together, and this would give you minus 28x. And then finally we have 169 minus 78 plus 6. So 169 minus 78 plus 7, that's 7, my bad. And this would give you plus 98 equals 0. Now I'm going to simplify this equation by taking 2 common, and this would give me x squared minus 14x plus 49 equals 0. Now two numbers such that when I multiply them, I get 49x squared, and when I add them, I get minus 14x. So that is very simple. It's 7 and 7. This would give you x squared minus 7x plus 49 equals 0. I'll take x common. It's x minus 7, and that would give you x minus 7 equals 0. And this is giving you x minus 7 squared equals 0. And this implies x is equal to 7. Since we are getting x equals 7, this means we are only getting one x coordinate. This means we would only get 1 point when we will simplify these two equations, or when we will solve these two equations simultaneously. And since we are getting 1 point, implies that y equals x minus 13 is a tangent. So we need to write down a formal statement at the end. Let me write that down. And that is going to be the equation has one repeated root, hence y is equal to x minus 13 is a tangent. Yes, any difficulties with this? Any confusions?